Hi, today I'll be explaining limiting reactants. So for the plain definition, limiting reactants are the reactants in a chemical reaction that react completely and determine the amount of product that is produced. And whatever is left over is the excess reactant. So this is a little complicated and wordy, so let's use a simple example to understand what limiting reactants are. So here we have 5 moles of sausage and 4 moles of bun 2, or a pair of buns. A pair of 2 buns. And for this reaction, we have 5 moles of sausage and 4 moles of bun 2. And for one hot dog to be made, you need 1 sausage and 1 pair of bun, or 1 mole of bun 2. And because we have 5 moles of sausage and 4 moles of bun 2, we're going to have 1 mole of sausage left over. And we're going to have all of the 4 moles of bun 2 reacted completely. This would mean that the limiting reactant is the bun 2, and the excess reactant is the sausage. Okay, so hopefully that gave you a clearer understanding of limiting reactants. And now for the steps defining limiting reactants of chemical reactions. So first, if the reactants are given in grams, not moles, unlike in the example previously, then you have to convert grams to moles. For the second step, you have to compare the coefficients in the chemical equation to find the reactant's mole ratio. And for step 3, using all of the information that you figured out in steps 1 and 2, calculate using the reactant mole ratio and determine the limiting reactant and excess reactant. Okay, so let's remember that limiting reactants react completely. This is a very simple rule of thumb, and just keep that in mind, and you're going to have a lot easier time doing these problems. So let's go on to an example. Here we have the combustion of propane, C3H8, with O2. And we have 100 grams of propane and 100 grams of O2. Which reactant is the limiting reactant? Okay, so let's just follow our steps that we reviewed, and let's figure this out. First, step 1, convert grams to moles. So the molar mass of propane is 44 grams, the molar mass of O2 is 32 grams. And for 100 grams of each, we figure out the moles for the reactants, which are 2.3 moles and 3.1 moles. Okay, propane has 2.3 moles. O2 has 3.1 moles. Okay, now step 2. Comparing the coefficients and finding the reactant's mole ratio. So for this reaction, if we look at the coefficients at the top of the chemical formula, we see that for every 1 mole of C3H8 or propane, 5 moles of O2 is needed. So in other words, the mole ratio of C3H8 to O2 must be 1 to 5. Okay, now we're done with 2 steps. Step 3, calculate and determine the limiting reactant and excess reactant. So let's assume that 2.3 moles of C3H8 propane is being reacted completely with O2 in a 1 to 5 ratio. And make sure that you understand the amount of ratio that is based on the formula. Okay, so here we have 2.3 moles of propane over X moles of O2 equals 1 to 5. Now remember, we're reacting propane completely, meaning that the ratio of moles of propane to oxygen gas has to be 1 to 5. So that's what this equation is based on. And doing the math, we need 11.5 moles of O2 to react propane. React all of the 2.3 moles of propane. So obviously that's not enough oxygen gas. We only have 3.1 moles of O2, whereas you would need 11.5 moles to react 2.3 moles of propane completely. This means that propane will not be reacting completely in this reaction, and that means propane is the excess reactant. And now we have the answer, but let's just keep going for good practice. Okay, so if 3.1 moles of O2 reacted completely with propane in a 5 to 1 ratio, then 3.1 moles of O2 over X moles of propane equals 5 to 1. Just the ratio turned into fractions, very simple. And again, doing the same math we did in the previous slide, we get 0.62 moles of propane required to react the 3.1 moles of oxygen gas completely. And let's look at the number of O2 moles we have for this reaction. We have 3.1 moles, and you need only 0.62 moles to react it completely, where we have 2.3 moles of C3H8 propane. So we do have enough amount of propane to react the O2 completely. This means the O2 will be reacting completely. So the oxygen gas O2 is the limiting reactant.